So, good morning, everyone. I must admit that preparing for this keynote was really tricky because I normally give presentations in the software engineering community, and this is the systems engineering community, and there are all kinds of things that I could have talked about that are very close to your heart as well. Things like platforms, software product lines, software variability management, software architecture, technical debt, all those topics I've done a lot of work on, and I know that they're really relevant to the systems engineering community as well. But what I decided to do is to focus on something else. I decided to focus on the increasing use of data in the way that we build systems or software in software-intensive systems, basically. So that's what we're going to be talking about in the coming 40 minutes or so. We're going to be talking about how do we move in the way that we build products from using opinions that may be valid and maybe are not valid to actually using data-driven facts. And in order to set the scene for that, I'm going to show you a number of slides. And the first is a quiz. Does anyone know who this fine specimen of the human species is? Does anyone recognize him? Not all at the same time? Henry Ford, very well. Henry T. Ford said, if I'd asked my customers what they'd wanted, they'd have said a faster horse. Yeah? Here is a second one, Marty Kagan. Customers don't know what's possible. It's very hard to envision a solution without actually seeing it. Another one by, sorry, I have to make sure. Yeah, Jacob Nielsen. The critical failing of user interviews is that you're asking people to either remember past use or speculate on future use of a system. Dean Leffingwell, the assumption that a reasonably well-defined set of requirements exists, if only we take the time to understand them, is wrong. Yeah? Customers don't know what's possible. Most have no idea about the technologies involved. And then finally, my favorite, Steve Jobs. You can't just ask customers what they want and then try to give it to them. By the time you get it built, they'll want something new. We've been in software engineering, and I noticed the same as systems engineering, for the longest time, we've been focusing on requirements engineering. How do we get an as crystal clear and precise specification of the requirements? Yes, so that we have something solid that we can base our design process on. And you know what? It's an illusion. Requirements, getting all the requirements before the start of the project does not exist. It's an impossibility. It doesn't work. The second is we've traditionally been very good, or at least we've been trying very hard to be good at doing long-term plans, having multi-year projects, and trying to hit the target at the end of multi-year projects. You know what? That's impossible too. It doesn't work. We've tried really hard, and we have to stop trying. We have to find other ways of doing things. Because one of the interesting things, and this would never happen in systems engineering, this only happens in software engineering. Yeah, but look at this. This is an overview. It's a rather old study that shows the number of features or functions used in a typical system. And what you can see is 7% of features are always used, 13% is often used, 16% is sometimes used, and then roughly 2/3 of the features are hardly ever used. Now, this is a very old study, and to be very honest, we didn't know if we could actually rely on this because there have been some criticism about the Standish group. And then we did a study ourselves in Sweden last year with a number of master students at the largest Swedish company, and we saw exactly the same pattern. Here at the bottom, you see all the features that exist in the system. And again, you see a very small number of features that get used very, very frequently, a few other features that see occasional use, and then a very large group of features that are actually never used. So we're in this very interesting situation that on the one hand, we have this constant pressure of delivering more functionality, more things to our customers, and on the other hand, we know that half of everything we build is actually waste. Our customers do not care about them. What I'm hoping to do with you this morning is to actually go through the thinking that we have developed within the Software Center that I'll talk about a little bit, and what we see in the software engineering community, which I think may apply to several aspects of systems engineering as well. Now, I saw all of you at the icebreaker reception last night, and I saw the amount of alcohol flowing, so I thought I'd keep it very, very simple. I have 3 key takeaways. Yeah? The only 3 things you have to remember from this talk. Number 1, Innovating new systems, solutions, and services at unprecedented rates is critical for survival. This requires speed in systems engineering. You know, I'm an outsider, but I've been looking at the way that Elon Musk and SpaceX and other private enterprises are trying to break into the rocket, sending rockets into space world, which traditionally has been very government-driven, very slow. And the interesting thing is that they focus on speed. They focus on speed to an extent that the traditional, more government-driven, more traditional approaches cannot keep up with. Yeah, and I think that that's one of the critical realizations that we within systems engineering have to get to. It isn't that we cannot build systems using the old methods and approaches. It's that other methods and approaches are so much more efficient, so much more effective in accomplishing the output that we will basically go the way of the dinosaurs there. Second takeaway. Oh, that's a second, I said. Embracing data-driven instead of opinion-based decision-making accelerates the innovation that we need in order to be successful. In many organizations, and I've worked in industry as well as in academia, a lot of people rely on opinions, rely on the experience that we've had accumulated over the last decades, the things that we know worked in the past. But in a world that is changing faster and faster, relying on experience and on opinions is not good enough anymore. We need to be much more data-driven. And then finally, systems engineering, I believe, and you're free to disagree with me, I believe needs to move from a focus on build to last. We put a lot of energy on building the best system possible so that once we put it in operation, it can sit there forever, to a focus where we say it's built to evolve. We try to get a version 1 out there as rapidly as possible, and then we evolve it over time. You're all looking at me as if I've rained on your parade, but that's at least the things that I was trying to get across. So that's what we're going to be talking about. Good. So what we're going to talk about is a little bit about who I am, so you have a feeling of where I come from. Then I'm going to talk about trends in software. What do we see happen in the software engineering community? And I think many of these things apply to the systems engineering community as well. Then I want to introduce the concept of innovation experiment systems and introduce you to how do we get there. We've developed a model that we've called the Stairway to Heaven. It's a much nicer song than the Highway to Hell, and it's a much nicer place to go to. So we developed it, we called it Stairway to Heaven. Then I have a few examples of things that we've actually been doing with the companies that we work with. And then I will spend a few minutes on the implications to systems engineering, which I think is quite important. That's what I was planning to do. Is that okay for you? I have a few other presentations, and I can pull those out as well. But this was what I had planned. Okay, very briefly about me. I used to be a young and innocent professor of software engineering. Then early 2000s, I got a call from a headhunter at Nokia who hired me as a vice president to run one of their research centers at Nokia Research Center. Beautiful place, 200 people working for me, 6 sites around the world. I had the best job ever. However, I'm not sure who of you have been to Finland. After the 3rd winter in Finland, on a Saturday morning, my wife puts me down on the couch, puts a cup of coffee in my hands, looks into my beautiful blue eyes and says, "Honey, I don't know about you, but I think we're moving." Which kind of complicated things a little bit, but luckily I'd been talking to a company called Intuit, which of course all of you know, so I decided to accept their job offer, became their VP Engineering Process, and moved to Silicon Valley. And then a few years ago, we decided to go back to Europe, aging family, all the things that come with that. And currently I'm director of a software center, and I want to spend a minute on this because I think it's a quite interesting collaboration. In the software center we have Saab Technologies, which is a defense company in Sweden, building anything from the Jaws jet fighter to airborne radar, ground-based radar, etc. Axis Communications, a quite successful company in Sweden, building web security cameras. Volvo Cars, the Chinese car company. The Swedes hate it when I say that, but Volvo Cars is actually owned by Geely, a Chinese automotive company, but operates very independently. Volvo, both the trucks, construction equipment, etc., is part of that as well. Then we have Jeppesen, a Boeing company. Ericsson, largest telecom company in the world. And then a company that many of you may not know, it's called Grundfos. Grundfos is a privately held Danish company, 18,000 employees, shipping more than 16 million water-based pumps a year. And guess what? All those pumps are increasingly holding software, and they are becoming connected to the internet, the whole Internet of things. And then we have a number of universities. The goal within the software center is fast, continuous deployment of customer value. And how should you think about this? Well, I used to say my dream is that the next Volvo car I buy, every morning I get into that car, there is some cool new feature waiting there for me. Yeah, this is not like, oh, the car doesn't start, or how interesting, we're driving without brakes. No, those are things that make the car better every day I use it. And interestingly, if you go to the new XC90, I will come back to the car in a bit, the new XC90 is continuously connected to the internet, and every 2 days, new software is downloaded into that car. Pretty cool, right? And this is not braking software, this is not engine control software, this is currently just infotainment software. Yeah, but the beginnings of a pretty big revolution is basically there. So, I didn't want to talk about that. Then, what I wanted to do is outline a number of trends in software engineering that I think have a lot of relation to systems engineering as well. And here is the first one. What we see in Sweden is that the nature of product innovation is fundamentally shifting towards software. If we look at Ericsson, Ericsson sold, I've been told that Ericsson sold its last steel mine in the 90s. Why did Ericsson own a steel mine? Because in the beginning of Ericsson's history, there were physical telecom switches, and the quality and reliability of the telecom switch was basically driven by the quality of the steel that I was using. Today, more than 80%, it's actually closer to 90% of all R&D in Ericsson is related to software. It's actually the 5th largest software company in the world. If we go to AB Volvo, 70% of all innovation in a truck these days is driven by software. The new truck that came out last year, you know what the major sales driver for that truck was? It was a feature that basically tracked where a truck is on the road. It will, the first time a truck drives over the road, it will measure where the hills are, where the curves are, when the driver needs to switch gear, etc., etc. And the second time a Volvo truck drives over the same road, it will know where the hills are, it will know where the curves are, it will know where it needs to stop, and it will adjust power and gears automatically before the driver does anything, which will cause a 3% reduction in fuel, which is a huge sales driver for a company in the trucking industry where fuel is a very big cost factor. Even in Volvo cars, 80 to 90% of all innovation in the car is what is related to what they call electronics, hardware and software, but the vast majority of that is software these days. So there was an interesting Harvard Business Review article recently that basically said, does hardware even matter anymore? And I think that's a really interesting question, but it's fundamental to understand how important software is to all the companies that I work with. Second trend, the entire world is moving from products to services. Yeah, I saw some people from Rolls-Royce here, but I think all of you know that Rolls-Royce jet engines these days are basically a leasing product. You do not own the jet engine, you basically get the jet engine as a service. Yeah, so for every flight hour, you actually pay. And Rolls-Royce takes care of maintenance and all kinds of other things. My friends at Volvo Cars expect that by 2020, between 1/3 and half of all their cars will be in a zip car-like arrangement. You will not own a car, you will have access to a car as a service. And especially with autonomously driving cars coming up, that trend will only accelerate. It has huge economic benefits to have self-driving cars as a service compared to owning your own car, because for most people, your own car is just sitting still 23 hours a day. Ericsson's fastest growing business unit that now already contains 40 or 45% of its revenue is a business unit called BUGS. I'm not making this up, it's literally called BUGS. It stands for Business Unit Global Services. It's the business unit that operators go to and they say, here's my network, you take care of it. Yeah, you're the experts after all, and I pay you a services fee. And the interesting thing that this leads to is that this creates an enormous drive for continuous deployment of new functionality throughout the entire economic lifetime of the product. Because suddenly, if I am a mobility company and I sell mobility, I don't care. Actually, I want to, rather than selling as many cars as possible, I now want to use as few cars as possible to accomplish the mobility needs of the people that are trying to get them from me. And that means I want to keep the cars on the road with a sufficient user experience as long as I can, and that requires that I push new software to those cars on a very continuous basis. Third trend, I will speed up a little bit. I don't have a clock, but I hope someone can warn me when I'm starting to run out of time, is innovation approaches. We used to think that if we have the best technology, we're going to win. But you know what? That's not how it works anymore. Yes, you need good technology. You need to be on par with the other players in the industry. But the companies that are really nailing it, that are really hitting the ball out of the park, are the ones that understand their customer better than they understand themselves. The companies that are able to predict the needs of customers before customers even realize that they have those needs. Yeah? This is when my wife tells me, trust me, honey, I know you better than you know yourself. That's basically the relationship that we're looking for with our customers. And how do we get there? Well, we get there by continuous experimentation with customers. Rather than going to the customers, asking what would you like us to build, or trying to come up with a requirement specification beforehand, we constantly experiment with new things coming to customers that actually may or may not work for them, and then drop the things that do not work. And to be honest, 2/3 or maybe even more of the things that we come up with that might add value to customers turn out not to bring value. Yeah, who is this fine gentleman here in Seattle? This should be easy. Jeff Bezos. You should wake up every morning terrified with your sheets drenched in sweat, but not because you're afraid of our competitors. Be afraid of our customers, because those are the folks who have the money. Our competitors are never going to send us money. So it's all about focusing on the customer. Then there is another trend. If we look at, and this has been really blowing me away when you look at these graphs, but if you look at the amount of software that goes into spaceflight, switching systems, automotive, Linux kernel, depending on the industry that you're in, the amount of software in those systems goes up with an order of magnitude every 5 to 10 years. Not with 10%, no, 10x, 10 times as large. And often people ask me, Jan, you've now been a professor of software engineering for close to 20 years. Have you still not solved the problem? How hard can it be? And then I explain to them that if you build a system that's 1 million lines of code, all the architectures, ways of working, tooling, testing approaches, etc., do not work when you're building a 10 million lines of code system. And when you're finally able to build a 10 million lines of code system, you don't know how to, those techniques do not apply when you're building a 100 million lines of code system. Yeah? And just to illustrate the point, I mentioned the XC90. I think you should all get one. It's a great car. That's what my friends at Volvo wanted me to say in return for me being allowed to use this slide. But basically, what you can see is the amount of software that goes into all the car models since 1998 until the new XC90 on the new platform that came out basically end of last year. So what you can see is it started to get around 100 megabytes. And probably for those of you in the back, this is the V40, which is a bit lower-end car than the V60, which is a higher-end car. That's why there was less software in there. But if you go to the XC90, there's close to 1 gigabyte of software in that car. Yeah, to hammer home the point, 90% of all the innovations in that car are electronics and software. Volvo Cars has been moving major parts of their software development in-house. They've hired somewhere between 300 and 500 software engineers over the last years. It's a connected car. It gets new functionality every 2 days. And the other one is Volvo used to think about the car as the system that they built. But they don't do that anymore. They now define their system. The system scope is the car, the cloud services, and the mobile apps that belong to it. And because now over your phone you can start your car, you can unlock it, you can lock it, you can do all kinds of things with the car. And that all is part of the system scope that this company has these days. Final trend, and I think that this is critical, absolutely critical to understand, because going slower is always easy and going fast is always hard. I have 2 slides on the need for speed. One, this is an illustration of how fast consumers are willing to adopt new innovations coming to the market over time. And we took 3 products, Quicken, I think all of you know Quicken, eBay, and Facebook. Each of these companies were introduced roughly 10 years apart. And look how long it took each of them to get to 1 million and 50 million users. Quicken, 6 years to 1 million, we never reached 50 million. eBay, 30 months to 1 million, mid-90s, 80 months to 50 million. Facebook, 10 months to 1 million, 44 months to 50 million. Does any of you remember Farmville, this little game you could play in Facebook? I lived in the Valley when that game came out. The rumor was they hit 1 million users in 48 hours. Yeah, that's pretty quick where I come from. If you don't like customers but you like money, here's another example. Yeah? I have a company. The company has a $1 billion product, $1 billion a year product. It's not unreasonable. R&D is often expressed as a percentage of revenue, so I put it at 10%, which gives me a $100 million R&D budget. In Sweden, I always have to ask if the math works for them, because we have some issues with our math education. But I think here I'm good, right? I just insulted the 4th largest group in this audience. I'm sorry about that. So my new product development cycle is 12 months. And now I will give you 2 alternatives. The first alternative is I'm going to focus everything I have on becoming more efficient. And lo and behold, I am successful, and I managed to become 10% more efficient, which gives me a $10 million reduction in development costs. That's pretty cool, right? I still ship after a year, but I've only spent 90 million rather than 100. How cool is that? But here's your second alternative. Yeah? Your second alternative is, I have reduced my development cycle with 10%. So rather than being able to start to sell after 12 months, I can now start to sell after 10.8 months. And assuming I'm selling at a flat rate of $1 billion a year, and assuming I'm not cannibalizing any existing products, that means I'm adding $100 million of additional top-line revenue. Now, what would you rather have, 10 million in savings or $100 million of additional revenue? Hello? It's pretty obvious, right? The interesting thing is, if you look at this example, no efficiency improvement will outperform cycle time reduction. There is nothing that you can do from an efficiency perspective that will be better than going faster. Speed is absolutely central. And the interesting thing is, all those companies that focus on efficiency, what do? They put all kinds of decision processes, boards, management layers, whatever in place, in order to make sure that nothing inefficient will ever happen in the company. By extension, nothing at all happens in the company. Yeah? So when you focus on efficiency, you get slowness as a byproduct. But what happens when you focus on speed? When you focus on speed, I'm not saying sacrifice quality, I'm saying automate and do other things. We're going to talk about that in a minute. If you focus on speed, you will identify all those activities that are not absolutely necessary, that are actually wasteful. And by focusing on speed, you will remove all the things that are not absolutely necessary to do as part of the development process. So what happens is that when you focus on speed, you will get efficiency as a byproduct, which is exactly what you wanted in the first place. So don't focus on efficiency, focus on speed, because it's a much better driver for improvement inside the organization. Now I want to spend a minute on what I call innovation experiment systems. And that's just a little bit more software specific, but I think there are a lot of learnings in there for the systems engineering community as well. So any guesses? What do these products have in common? You know, I used this recently for a group of students at Chalmers, and the student said, you know, Jan, what these products have in common, they're all old. That was not what I was looking for. Yeah? So, sorry? No one wanted them. That's an interesting one. I think a lot of people wanted them. All right, that's that is actually an interesting point. But the interesting thing is, this is my first mobile phone, not the actual picture, but this was the phone that put Nokia on the map as the maker of the most user-friendly mobile phones. Yeah, here is the iPhone. You remember the first time you used a touchscreen phone, you touched the screen, and the phone responded. What a fantastic experience that was. Intuit introduced QuickBooks in 1993. It went from a newly introduced product to #1 in the market in 9 months, and it had 1/3 of the features of competing products. But we got it right. The Prius, I lived in Los Altos Hills, and I was renting. I didn't buy a house there, let's be clear. But I mean, there were all these very high-end cars and many Priuses, because when I drive a Prius, I tell the entire world, yeah, you know I'm green. Can you see how green I am? Pretty cool, right? You know, this thing is the summum of citrus presses. Can you see it? Okay, I can't, but my wife reminds me on a regular basis. I have no feeling for aesthetics whatsoever. But this was actually interesting because I used this slide once in Silicon Valley. After the talk, a guy comes up to me and says, oh, Jan, interesting, you showed the citrus press. I have one. I said, how cool, tell me. He said, I come home one day, there's a box waiting for me. I open the box, out comes the citrus press. I said, wow. He says, you know, it gets better. I look at the citrus press, the thing is gold-plated. I go like, wow, this only happens in Silicon Valley, right? He says, you know, it gets even better. There's a note in the bottom of the box that says, please don't use the citrus press to actually press any citrus because the acid will damage the gold layer. For all the chemists in the room, this was not real gold. I guess you figured it out one already. The problem with the previous slide is that we create this myth of this big breakthrough innovations that you have to do basically by going to the Himalayas and sitting for years on top of a mountain, meditating on the next big thing to happen. And then, you know, after 6 years, when the sun is sinking into the ocean, you finally get struck by lightning. You have this eureka moment, and you run down from the mountain. And you go to your colleagues after you shower and shave if you're a guy, I suppose, because you smell a little funny. And then you run to your colleagues and you say, eureka, I found it. Yeah, that's how we tend to think about innovation. And the problem is, it's a complete and utter myth. Yeah, the company that is best at keeping that myth alive is Apple. Have you seen, when Steve Jobs was still alive, the Apple product introductions? Big stage, loud music, flashing lights, fog on the stage, and then Steve Jobs would say, I give you the iPhone. Remember that? But you know how they really do it? How they really do it, and there's a nice Harvard Business Review article if you're interested. For every major new product, every major new feature, they create 10 pixel-perfect prototypes. And then they get feedback from their customers and their employees, and they go from 10 to 5, from 5 to 3, and from 3 to 1. And that one thing that comes out is pretty darn good. And there's another Apple person standing on stage saying, I give you the iPad. Did you know you needed an iPad? I have 5 iPads at home. We are a family of 5 people. Yeah? So clearly, this process is working. So the whole point is, yeah, where's the world going these days? And this is more software, but I think it has huge implications on systems engineering as well, is we have those sprints. You all know Agile. We have an Agile track today. We have these sprints, 2 to 4 weeks, and at the end of every sprint, or even more frequently, I push my functionality out to my installed base. And then what I do is I do not only push the functionality out, but I also instrument my system so I collect data from what is actually happening in the field. So I use that data, and I get that back to my R&D team. And based on the data that I get back, I can start to make decisions based on whether this was a good idea or not such a good idea, etc. It's a very simple model, but it allows me to move decisions from opinion-based decision-making to data-based decision-making. Whenever at Intuit we had to decide, shall we do A or shall we do B, we always got into this big discussion until we changed to this model, because then it was easy. Then we said, okay, what is the easiest, cheapest way to try out A with customers? What is the easiest, cheapest way to try things out with, to try B out with customers? And then we tried A out and B out with some selected customers. We got the data back, and then decision-making was easy. Yeah, so this is where the world is going. The companies that are going to be successful are the ones that can run the largest number of experiments with customers against the lowest cost per experiment. And this now is the norm in the software as a service world. Yeah? Every company from eBay, Microsoft, Intuit, etc., are all on their online software doing this continuously. I was at Microsoft yesterday, and they told me that the Bing search engine runs 10,000 experiments per year. They have 200 to 400 experiments running in parallel in their software. And the thinking is, you know, this is, of course, something you can only do in software as a service. Well, that's the point I'm exactly trying to get to. With all the embedded systems, with all the systems that you're responsible for, becoming connected to the internet, we're starting to do this today in embedded systems. I can do this in cars. I can do this in telecom systems. We are starting to do this in cars and telecom systems. Yeah, so you know, Ray Ozzie from Microsoft, we have an unprecedented opportunity to run A/B tests with online users and innovate more quickly based on actual user response. Microsoft needs to shift the culture from planning the exact features of what we're going to build to planning a set of possible features and letting customers guide us. And I believe that also in the systems engineering world, with everything becoming connected to the internet, we can start to apply, and we are starting to apply, the same principles in the companies that we work with in the software center. Why do we care so much about getting stuff out fast and getting data back fast? It has to do with the cycle of innovation. I think you've all read about innovation, but innovation is really a very simple process. You build something resulting in a product. You measure how that product is used. So did it actually result in what you expected? So that gives you data. That data you can learn from, and that learning leads to new ideas. And the companies that can run this cycle faster are the ones that are going to be successful. The ones that run this cycle very slow are the ones that will have much more difficulty to be successful in the market. And what you see is that the companies that run this very slow typically work in very protected markets with huge barriers to entry. But those barriers are going away. Yeah, I think that that's important to realize. So a few examples. The length of the innovation cycle. So build, measure, learn. A car platform typically lives for 10 to 15 years. So you design the platform, and then you build a range of cars on top of it, but the platform doesn't really change. So your build, measure, learn cycle is about a decade and a half. If we go to a car, currently Volvo Cars has a 36-month development process for a new car. Yeah, it's 3 to 4 years. We're basically saying that my build, measure, learn cycle is 3 to 4 years. Now I go to car software. My car is connected to the internet. I can get new stuff out on a very regular basis, which means that I can do this basically multiple times a day if I want to. I can every week, I can download new software every other day. Yeah, so do you see the difference? I can go through the build, measure, learn cycle much, much faster if I use bits than when I use atoms. And that, you know this fine gentleman, George Colony, CEO of Forrester Research, one of his quotes is, and that's why in the future all companies will be software companies. You didn't like that one, I think. But this is really where the value of a lot of stuff is going. At least that's what I see in the Nordics in Europe. So how do we get there? Well, we've defined something that we've called the Stairway to Heaven model, which is a descriptive model based on dozens of companies that we've worked with on how companies evolve over time. So starting with traditional development, the first step that happens is that the R&D organization starts to use Agile as a development practice. And this is the software R&D, but even in other parts of the organization, people are starting to, through the use of simulation and other techniques, you become more agile in the way that they do things. Yeah, actually, I've worked with several companies where the hardware engineers that used to be able to sit by themselves in an office with big headphones on for years designing an ASIC are becoming really frustrated because suddenly they have to work in teams and become more agile. But that's, I think, really accelerating them. Once you are able to go agile, the next step is continuous integration. Everything you build and construct, you immediately test in order to validate that what you've built actually works and that the things that used to work before you started to make changes in the code still work. Yeah, so that's the continuous integration state. This means, at least for software, for hardware, of course, the simulations have to be proven once I start to generate the real stuff. But at least for software, it means that I can always ship. We will never be in a situation anymore that we can't ship. The only thing you have to decide, do I want the software with this feature? Then I may have to wait another few sprints. Or can I live with having the software without a feature? And that's actually happening in a lot of companies. So what happened is that Ericsson, for instance, a Nordic telecom company whose name I will not mention, has become very good at continuous integration. And when they went out to customers, the customer said, and this happened with, well, I'm not going to mention which customer it was, but the CTO of that customer said, so you're telling me that you have these new features that I want to have, and they're ready and tested, and you still want me to wait for the release 6 months from now. That's not good enough. I want it now. And that's when the company starts to move to continuous deployment, where now, at the end of every 3 weeks, with selected customers and with selected players, the software is basically pushed out to live networks that have 5-9 uptime requirements. Yeah, 99.999, sometimes even an additional 9. So then you get 6 nines, and they can do continuous deployment of software in systems with such strict reliability requirements. Once you have that, once you can do continuous deployment, then you can start to use your R&D as an innovation system. Rather than saying, I have my requirement and I'm going to build it, I'm going to say, I have this feature. I think this feature will add value to my customers. But what I'm going to do is I'm going to build a small amount of that feature, maybe 10 or 15%, get it in the hands of customers, get data on whether it actually works in practice or not, and then decide if I want to invest more into this or not. So why do we care so much about it? Isn't this just something that weird software geeks with propeller heads want to work on? No, actually, what we did is at some point a quick back-of-the-envelope calculation. Yeah, traditional development, if we assume it has 30% waste, according to most people, most engineers that I talk to, traditional development has closer to 100% waste, but let's not go there right now. 100% waste, you got it, right? Yeah. And if I say that with every step I go up, I get rid of 5% waste, what does that mean for companies like Ericsson and AB Volvo? Well, Ericsson had a close to $5 billion R&D budget between 2011 and 2012. 80% of that, close to $4 billion, was software R&D. So removing 5% waste gives me $200 million of resources that I can use on value-adding stuff rather than on wasteful stuff. This is only one step on the stairway to heaven. AB Volvo, a company around 16 billion Swedish kroners in R&D budget, around 25% of that is software these days, still 200 million Swedish kroners. It's a nice chunk of change. So there are real financial benefits to doing this. So once I have this capability, can anyone give me an indication? How am I doing on time? Because I have to talk. I'm okay? Yeah? I have two frameworks that I want to spend a minute on, but the first thing that I want to do is give you a bit of an understanding of what are the engineers, and these are not just software engineers, these are also systems engineers, telling us when we talk to them. We don't know what features our customers use. We can see that some functionality is used, but we can't see how it's used. We get feedback only on things that don't work, things that are problematic. This is not necessarily an indication of what is used most. Does silence mean that things are okay? We don't know. Yeah, so what we have is a situation in which R&D organizations operate in a complete vacuum and have very little understanding of what is actually happening in practice. The other thing that we noticed is that we have very slow feedback loops. So there is a lot of data being collected, but all that data is only used for the next version of the car. So Volvo Cars is a good example. They collect lots and lots of safety-related data. How are our cars performing in the field? This is not just software. This is anything related to safety. But rather than using that data to make my car that I bought from them last week better, they actually use that data to make the next car better. Yeah? Not the model that I just bought. Another interesting thing is that all these companies have lots and lots of data. I'm sure if you go and look around in your company, you will find terabytes of data, but they only use it for troubleshooting and support. Yeah, so they use it when the system doesn't work as the customer was expecting. And actually, when we started this research a few years ago, we started to look, we asked all of the companies in the software center, do you know which features are used and which features are not used? And none of the companies were able to answer that question. They're not using the data to measure feature usage, whether a feature is an improvement or to support new feature development. And then finally, and I'm going a little bit fast, and come and talk to me afterwards if you're interested in learning more, we have the open loop problem. In all of these companies, we have product management with the money and the requirements on the one hand, and we have R&D on the other hand. And basically, product management prioritizes the content of the next release based on what they think will add the most value. But then when it gets built, we never really measure and learn from the fact whether the prioritization of the product managers actually delivered the value that they expected or whether it didn't. And that is a real challenge, and we need to become much better at that. The other thing that we realized is that although many people may know about A/B testing, the world is much broader than that. So what we saw is that there is a model where in the beginning, before I even start any development, I can actually collect data. Typically, that data is small in size, it's qualitative in nature, and the customer is aware of the fact that I'm asking the customer for feedback. And then when I go up, the data becomes increasingly quantitative, the amount of data becomes increasingly large, and the customer becomes increasingly uninformed of the fact that my system is being used. I mean, if you go to Facebook, I don't think you really think about the fact that every click, the amount of time you spend on any page, yeah, is actually measured. And I know that for a fact that many embedded systems products are now getting more and more into the same approach, where they basically collect user behavior, systems behavior, etc. A company like Ericsson is collecting lots and lots of data on how their networks are performing in the field. Yeah, in order to deal with this, we developed two models just to give you a taste for the kind of things that we're working on. One is the HyperX model. This is a bit more narrow. It's about a process model for conducting feature experiments. The model is very simple, as you can see. Yeah, your systems engineers, most software engineers start to laugh when I say that because they're used to simpler models, but your systems engineers and consequently much smarter. So you to handle this. So the idea basically is you start from a strategic product goal, you get a feature backlog, the kind of things that we would like to see in the system, and I pick one, and the first thing that I do is I start to ask the people that are responsible for picking and prioritizing features, if I implement this feature, what behavior will I see in the system? How will I see the system change? How will I see the customer behavior change if I build this feature? And that leads to the expected behavior. Then I build the minimal viable feature. If you've read Lean Startup, they talk about a minimal viable product. We talk about a minimal viable feature. So you build the 10 or 15% of the feature, and you get it out into the product together with instrumentation to collect data that allows you to actually measure how the system is used actually compared to the expected. So I get actual behavior, and then I can compare in a gap the gap between expected behavior and actual behavior. And trust me, if you get it right the first time, you deserve a Nobel Prize, because in our experience, the expectations of the value is always far, far off. And when you have that gap, you have basically two typical alternatives that come up. The first is the team says, you know, we built this 15% of the feature, but before we're going to see this expected behavior, we have to build more. So we build another 10 or 15%, and then we measure if it gets closer. The second is, you know, I looked at the data and I realized that the way that we implement this feature is completely different from what our customers were expecting, and because of that, I have to come up with an alternative implementation. The other outcome that you may have is you implement some of the functionality, you see no movement whatsoever. Yeah? Or it is actually negative. It drives down some of the metrics that you care about, and then you can actually abandon the feature. Just stop development, remove it from the system, and don't go any further. And even if you are slowly closing the gap as you go through this loop, when the amount of added value of every slice of the feature that you're adding is starting to diminish, you can actually decide that once you've built 60% of the feature, it's good enough. The other 40% are not worth building. Yeah, so that's the HyperX model, purely focused on features. We have a whole set of practices around this. I won't tell you about those today because I wanted to spend a few minutes on the QCD model. The QCD model is qualitative, quantitative, customer-driven development model. I knew you would love that title. And the idea basically is that what we realized that we wanted to not only use this hard quantitative data, we wanted to complement it with qualitative data as well. So the model is very simple, as you can see. Rather than having a set of requirements, I have a list of prioritized hypotheses. Hypotheses about what will add value to the user or to the system, and how important is that. These hypotheses come from all kinds of inputs: business strategies, innovation strategies, qualitative customer feedback, quantitative customer feedback, results from earlier QCD cycles, etc. Then what we do is we pick one hypothesis, one that is high up in the priority list, and I pick a customer feedback technique. And customer feedback techniques can be qualitative techniques like surveys or participant observation or prototypes or mock-ups or whatever, or they can be much more quantitative. I can measure feature usage, product data, I can look at all kinds of other things. So I select the customer feedback technique, and then I, if my clicker works, go to the next stage where I get it out to deployed products or to selected customers, or to deployed products at selected customers, and I get the data, and based on that data, I can decide if it's very promising. I prioritize the hypothesis and it goes up in the priority list. If the data is not so promising, I deprioritize it and I put it lower in the priority list. And if the data is awful, then I will basically abandon the development of the feature altogether. Yeah, I will throw it off the list. This allows me for continuous prioritization of hypotheses. Yeah? This is all about the speed stuff, rather than having a requirement specification for a system that I've developed, have to deliver in 3 or 5 or 10 years. We basically continuously reevaluate what is the most important thing for our R&D staff to spend time on. I think I'm starting to run out of time, so I want to spend a few minutes on implications for systems engineering. The first, every system, every platform, every portfolio of products has a chunk of functionality that is commodity, stuff that you need to have for the system to work, but your customers are not going to pick you over one of your competitors because of that commodity functionality. And there is a layer of differentiating functionality, that which makes your product unique and special, and your customers will pick you over the competitors because of that functionality. As we look over time, what we see is that increasingly in more and more systems, the software is defining what is differentiating, and for all, and the mechanics and the electronics are increasingly becoming commodity. You know, I know I'm biased because I'm a professor of software engineering, but that's basically what I see happen in the Swedish industry. And if we look at the allocation of R&D resources, they're really being pulled away from mechanics and hardware development, and people go much more to commodity solutions or commercial solutions or even open source solutions. And increasingly, they put their resources on software. Yeah, Ericsson is an extreme case, but now in the automotive space, we see happen the same thing. In the defense space, we see happen the same thing. In the web security cameras company that I was talking about earlier, we see that almost all of the R&D staff is in software. So this is just a reality. It may not be the message that you want to hear, but it's still a reality that I see. So what does this mean? For me, the implication is that whenever you have to make decisions about, am I going to build this in mechanics or in electronics or in software, the first rule has to be the opposite from what most of you, I think, were deciding earlier. And that is, build it in software unless you really, really, really cannot realize that functionality in software. Because if you put it in software, you will have the fast innovation cycle. If you build it in atoms, it will be slow. If you really can't, then you have to build it in hardware. Then build it in hardware, but not in mechanics. And keep it flexible. Yeah? So many companies are moving from selecting ASICs, which are static and you can't really change, to FPGAs. Even though they're a bit more expensive in the bill of materials, the FPGAs give you the ability to reconfigure the functionality of your system after you've put it in operation. Yeah, so focus on flexible hardware solutions that preferably can be reconfigured after the deployment of the system. And then finally, if you really, really can't build it in software and you can't build it in electronics, then build it in mechanics. But if you have to, but keep it modular, easily replaceable, and simple. Yeah, and that's what I see. So if you want what I see in the world of systems engineering happening is a few things, a few implications. First, we have a lot of focus, and I walked around yesterday at the conference and I got a lot of perception of that we're focusing on systems that we build once and then they will last forever. That's the wrong perspective. We need to start to focus on systems that are built to continuously evolve. In software, there's a rule. Any software that doesn't change continuously is dead. Yeah, any system going forward that doesn't continuously evolve is dead. Yeah, so that's the first thing. So from systems that are built to last to systems that are built to evolve. Second, opinions-based decision-making or experience-based decision-making needs to be replaced with increasingly data-driven decision-making. Quick note, Booking.com. Yeah, I think you all know Booking.com, hotel bookings, Priceline company. They asked the senior management of the company to come up with 40 ideas that would improve the functionality of the system. Yeah, that would get more revenue to Booking.com. Yeah, so they took the 40 ideas that they got from the leadership team, this included the original founders, and they tried all of them out using the experimentation approach I mentioned earlier. 3 of them had a positive impact. 30 of them had no impact whatsoever. 7 of the ideas had a negative impact on the performance of the product. And 3 of those ideas were so bad that they had to stop the experiment within 10 minutes because customers were starting to call customer support. This is the leadership of the company coming up with what are their best ideas about how to take the thing forward. Yeah? So be very careful on making opinion-based decisions. The other thing that we talk a lot about is deeply integrated architecture. How do we get everything together so that we can optimally guarantee the different abilities and architectural qualities of the system? And we need to move away from that, and we need to move to much more modularized approaches that allow us to do a lot more at the module level rather than at the overall system level. The overall system level has never been more important, but the complexity is becoming so large that we have to start pushing things down. A hierarchical organizational model is what we've been using in the past a lot. Yeah? We're organized in hierarchies, and there are different decision processes that go up and down the hierarchy. And increasingly, we see companies move to an ecosystem of partners that all have their own drivers, but they all contribute to not so much a system of systems, but perhaps more of an ecosystem. Otherwise, satisfying the requirements is making place for constant experimentation and innovation. And then the whole notion of I built a system and I certify it statically and then I won't touch it anymore because otherwise I have to recertify will make place for dynamic, continuous certification. I was talking to one of the companies downstairs yesterday during the icebreaker, and they have processes to basically support 26262 standard support while working with Agile and continuous deployment. So these things are starting to become reality, and you have to make use of them. Conclusion. You've never been so happy to see a slide that says conclusion, right? I can see it. So here are my 3 key takeaways. Innovating new systems, solutions, and services at unprecedented rates is critical for survival. And this requires that you really become much faster. I mean, I see in all kinds of industries that were the bread and butter businesses of very big, hierarchically organized, slow-moving organizations being attacked by new players, people that take kind of a software engineering mindset. Elon Musk is, I think, a really good example with SpaceX, but you can also see it in Tesla and in other players. Yeah, so we have to become much faster, not 10% faster, 10 times faster. That's the first takeaway. Second, embracing data-driven rather than opinion-based decision-making is critical because it accelerates innovation. And the biggest one here is beware of the Hippo. You know what the Hippo is? Highest paid person's opinion. The higher up you are in the organization, typically the longer you've been there, typically the longer it has been since you were a frontline employee, actually in touch with the market and the customer and the newest technologies, and the least suitable you are to make these kind of prioritizations. I know that that's a painful statement in a room where the average age is not 18 anymore, I suppose. But it is true. Rely on data because your experience in a faster and faster moving world is becoming increasingly unreliable. And then finally, build to evolve. Legacy systems don't need to be slow. There are very good ways to move much faster with legacy systems. Now then finally, before I let you go, who is going to make this a reality in the systems engineering community? I used this slide recently at Ericsson, and one of the product managers at Ericsson said to me, you know, Jan, at Ericsson we would have bent the road too, which I thought was kind of funny. This requires strong leadership. It is really hard to drive changes. Basically, the whole software center is about helping the companies in the software center change faster. And it is a really hard uphill battle. And I think that all of you need to take on that battle and do that within the organizations that you're part of. And then I will let you go with the final quote from Admiral Grace Hopper. One accurate measurement is worth more than 1,000 expert opinions. And with that, my friends, thank you very much for your attention.